Neutralization reactions. These are between an acid and a base. We've talked about these before, but now we have a little more understanding of what acids and bases are. So here we have HCl, that's an acid, and here we have KOH, this is the base. They're going to react to form water and a salt, right? The net ionic equation for many of these is H plus OH minus to give water. Because what does this do in solution? It becomes H plus and Cl minus, right? It ionizes. And KOH is a soluble metal hydroxide. That becomes K plus and OH minus. So the hydrogen ion and the hydroxide ion become water, and the KCl becomes the salt. Here the salt was aqueous. So it's still ions. The water is a molecular substance, and so when we write the net ionic equation, we do not include the spectator ions, but we do include everything else. And so H2O, becoming a molecular compound, stays, and then the H plus and the OH minus have to stay. So here the hydrogen ion this is the acid. It's donating its hydrogen ion to the base, which is accepting the hydrogen ion. We did a reaction like this in class, HCl plus sodium hydrogen carbonate. This generates CO2 because it forms carbonic acid, which is unstable and decomposes. It's a gas evolution reaction, but it's also an acid-base reaction. Write a molecular equation for the reaction that occurs between aqueous H3PO4 and aqueous NaOH. And it says hint. H3PO4 is a triprotic acid, meaning that 1 mole of this requires 3 moles of hydroxide to completely react. So H3PO4, all 3 hydrogens are written at the beginning. At the beginning. That means that they are all ionizable. So 3 hydrogen ions can come off. So molecular equation, we got H3PO4 reacting with sodium hydroxide. And the way you predict what's going to happen here is you separate them into ions and you swap partners. So when you break this into ions, we're going to break it into 2 ions. It's going to be hydrogen and phosphate. Sodium hydroxide is sodium ion and hydroxide ion. And then swap partners. So over here we're going to have sodium ion with phosphate ion and hydrogen ion with hydroxide ion. Sodium ion and phosphate ion, 3 minus. We just look at the charges to put them together. Na3PO4. And then H plus and OH minus form water. And so there's the predicted products. We need to balance the equation though. Here we have 1 phosphate and 1 phosphate. Here we have 1 sodium and 3 sodiums. So I need to put 3 in front of sodium hydroxide. And that's where this is talking about 1 mole of phosphoric acid requires 3 moles of hydroxide. It requires 3 moles of sodium hydroxide. And then I'm going to end up with 3 moles of water. Because I have 3 hydroxides and 3 hydrogen ions, and they're going to make 3 moles of water. Any questions? So acids dissolve many metals, but not all of them. We've done this one, magnesium with HCl, generated hydrogen gas. Zinc can be dissolved by sulfuric acid, again giving hydrogen gas. Iron will react, but not all of them do. And it depends on that activity series that we peeked ahead and learned about. So, usually what happens when you have an acid and a metal is that you're going to get hydrogen gas and a dissolved salt. So when these happen, it's a single displacement where the hydrogen and the magnesium are switching places. And so then you have hydrogen gas all by itself, and magnesium gets the girl. So as long as the metal is above hydrogen on that list of who's more active, the reaction will occur. Acids will react with metal oxides to produce water and salt. So knowing that, let's write these equations. Hydrochloric acid with strontium metal. So HCl plus strontium. If they're asking you to write the reaction, you can assume that it's going to occur. So what's going to happen here is strontium is going to swap places with hydrogen. So hydrogen's going to leave by himself, and when he does that, he always takes a friend. And then I'm left with strontium and chloride. I have to look at the charges of the ions they form. Chloride's -1. What's this ion that would form for strontium? 2+, because it's in group 2. So then this is going to be SrCl2. And then I have to balance this, so I'm going to need 2 HCl's. A metal and an acid is going to form hydrogen gas and some compound. Here we have hydroiodic acid and barium oxide. So hydroiodic acid is Hi, and barium oxide, barium is a +2, and oxide is -2, so this is BaO. We know from this slide that acids react with metal oxides to make water and salt. So this one's a little harder because you can't just do a displacement sort of a thing. So it's going to make water, and that's going to occupy the hydrogens and the oxygens, and the other 2 ions, the barium ion and the iodide ion, are going to get together. So that'll be barium iodide. And then you have to balance it. 1 barium on each side, 2 iodines on the right, so I need 2 on the left. I guess you could think of this as double displacement. You've got H+ and I-, and you're going to have H+ with O2-. Looks a little weird to me, but this is not a big deal. Questions? Base reactions, the most important ones are the acid-base neutralization reactions. We've already covered those. The only other one we're going to talk about is the reaction of aluminum with sodium hydroxide. Aluminum is one of only a very few metals that will dissolve in bases. Most metals will not react with bases. We did this. We dissolved aluminum foil in potassium hydroxide when we made the alum. We took the little pieces of foil and we put them in a beaker and put KOH in them. It generated hydrogen gas and this crazy compound. So you do not have to remember that balanced chemical equation.